particular video, we have a meter stick that is mounted 20 centimeters away from the end. So here's the diagram, there's the pivot, and it wants us to calculate the period of oscillation. So let's go ahead and put this 20 centimeters given to us appropriately. So my red arrow there, that just came up. Again, this is just to help you visualize, not drawn a scale. I'm just going to label that 20 centimeters. Keep in mind a meter stick, which is a meter long, which is 100 centimeters, because 1 meter is 100 centimeters. So the problem says 20 centimeters, but really 20 centimeters is just 1/5 of 100 centimeters. So essentially I'm just going to denote 20 centimeters is equivalent to the length of the meter stick divided by 5, because it's 20 is 1/5 of 100. Okay, so that's why it's equal to L divided by 5. Here, the function to find the period of oscillation for a physical pendulum is 2 pi times the square root of the moment of inertia divided by mg times d. Well, the moment of inertia here is for the rod where it's pivoted. And then the d in the denominator here is defined as this distance from pivot to center of mass. So it's important that you apply these physics functions correctly and not just plug in any random value, okay? All right, so I highlighted I and D because these are the two things I don't know. So I do need to figure out what these two values are before I can crack it out. And I do want to point out that while the function here has an m for the mass of the object, in this case the mass of the meter stick, you notice that in the wording it never specifies anything about the mass of the meter sticks. So hopefully if you watch, you can see why that is not relevant for this particular problem at all. Okay. All right, so let's go ahead and find I and D. So I'll just go ahead and help you with this. D is defined as the distance from center of mass to where the pivot is. So roughly about where this green arrow is, that's starting from the center of mass, and it's going to measure to where the pivot is. I don't know what this length is, so I'm just going to call that D. Okay, again, D is the distance from pivot to center of mass, or center of mass to pivot. But what I do know is, well, because it is a meter stick, the distance to the center of mass is just half of the length. Right, that's just common sense. Okay, so the center of mass for the meter stick would be placed right in the middle where my cursor is resting right now. So that blue arrow that came up is half of the length of the meter stick, so that just be L over 2. Well, we're just going to use a little common sense here, basic math, call it whatever. We'll take the length of the blue arrow, subtract it from the length of the red arrow. The difference should be the length of the green arrow, right? So therefore I can make the statement. I can see that D is equal to the half of the meter stick, or the blue arrow, which is half the length, minus the 20 centimeters that was given to us, which I said earlier is just L over 5. From there, that equals to D. So here we have L over 2 minus L over 5. As you can see, the denominators are different, so let's find common denominator. The common between 2 and 5 is 10. So to get this term on the left side here, L over 2 to have a denominator of 10, you just multiply top by 5 and bottom by 5, so hence it's 5L over 10. Likewise with the term on the right side here of L over 5, well, to get the denominator to be 10, you just have to multiply 5 by 2, and what you do in the bottom, you do the top, so it becomes 2L on top and then 10 on the bottom. So now we can just simplify. 5L minus 2L is 3L, common denominator being 10. So really the distance here that was shifted from the center of mass to where the pivot is a distance of 3L over 10. Okay, now I want to keep L in my function because I want to show you how to do this problem using variables just in case it's not a meter stick. So really the length here is just 1 meter, and multiplying by 1 of course makes things easy, but I'll keep it as L for now. Okay, so the next thing I need to find is the moment of inertia in yellow. Again, to find the period I need a few items. Okay, I need I and D. I just found D. I need I. Well, to find I need to apply the parallel axis theorem because this particular pivot is not at the center of mass. It got shifted a distance of 3L over 10. Well, to find I is pretty light work. You would just have to apply the moment inertia referencing center of mass plus the mass of the object itself, and then D here is the distance shifted from center of mass. Well, here ICM for a rod is just 1/12 ml squared, referencing center of mass. And then M gets carried down, and the distance that I found already, the distance shifted from center of mass to where the pivot is a distance of 3L divided by 10. Well, here I'm just going to distribute the square. So 3 square is 9, and then 10 square is 100. So the first term, the 112 ml squared, remains the same. And the second term, once again, the 9 is because 3 is squared. And then the 100 is because the 10 on the bottom is also square. And then it would just be ml squared because L is also square. Okay. So as you can see here, we have 1 over 12 ml squared plus 9 over 100 ml squared. Well, at this point, just find common denominator. The common denominator between 12 and 300, and 100 is 300. So to get 12 to be 300, you would just multiply 12 by 25, and then the numerator here is just 1, so 1 times 25 is just 25. And then to get the right term here, 9 over 100, to be, to have a denominator of 300, just multiply the bottom by 3, so 100 times 3 is 300. But what you do on the bottom, do to the top, so 3 times 9 is 27. So as you can see here, we have 25 plus 27, which is 52, and then the common denominator here would just be 300. Okay. Once again, if you want, at this point in this problem, you can plug in L as 1 meter because it's it's a meter stick, so the length is 1. But I'm just gonna keep L square just to show you how to play with these functions. All right. And that I'm just gonna plug it in. So here, I'm just gonna carry down the work to 2 pi in front of the radical stays the same. Wherever I is, I'm going to substitute in 52 ml squared divided by 300. The 52 is because 25 plus 27 is 52, and that's where the 52 comes from. And then on the bottom, the m and the g got carried down, and then the distance from center of mass to pivot is calculated to be 3L over 10. Well, here you have a fraction on top, you have a fraction on the bottom, so just multiply by the reciprocal. So I'm just going to do a little quick algebra move for you here. The fraction in the numerator stays the same, so that's just 52 ml squared divided by 300. And the fraction on the bottom, so it would be mg times 3L divided by 10. So when you divide by a fraction, you multiply by the reciprocal. So therefore, the 10 now is in the numerator, the m, the g, and the 3L is in the denominator. So as you can see here, m is going to cancel out. So as I stated earlier, the initial problem didn't give you the mass of the object, in this case the meter stick. Why? Because it's going to cancel out. So keep that in mind as you practice. Okay, the period of oscillation of a physical pendulum is independent of the mass of the object. As you can see, it cancels out in my work. The term here, L, is L squared, but the L on the bottom is just L. So I'm going to cancel out the exponent 2, and that's going to cancel one of the L's here. So really I'm just going to clean up a little bit. The numerator is just 52L times times 10. So 52 times 10 is just 520, and the length here is just L. And then on the bottom, it'd be 300 times G times 3. So 300 times 3 is 900 times G. So I just carry that work down. Once again, L, we already know for this particular problem, it is a meter stick, so the length is just 1. So here's 1 meter. And then G being 9.8, because this is, I'm assuming this is on Earth. And if it's not on Earth, then just plug in whatever G it is. That's relevant. Okay. Other than that, if you just do calculator work, so it'd be 500 divided by the product of 900 times 9.8, and then square root that, and then times that by 2 pi. I did that on my calculator, and I'm running out of space, and I got a value of about 1.53 seconds. Okay, and that is the answer for this particular problem. I hope that helps. Make sure you apply definitions correctly. Right, find the proper I value. Don't make false assumption. Find the distance from center of mass to where the pivot is. Make sure you do algebra correctly, and hopefully that'll lead you to the right value. Alright, I hope that helps. Stay nerdy, don't be wired.